In this video, I'm going to talk about the use of the force model for a horizontal acceleration type problem. So let's take a look at a car that goes from 0 to 60 in, let's say, 5 seconds. So I have a car here, and it's going to go from velocity of 0 meters per second. So let's say 60 miles an hour, which is roughly about 30 meters, roughly half, 30 meters per second. And let's say it does this in a time frame of 5 seconds, which is pretty fast here. 5 seconds. It accelerates from 0 to 30 meters per second in 5 seconds. And the question is, how much force is acting on the car? The force of, let's say, the engine acting on the car to accelerate it at this rate. And let's say the mass is 1,000 kilograms. 1,000 kilograms. Okay, so we want to find the force on it. So the force model is a three-step process. The first thing we do is we draw a free body diagram. So it's an object, a picture of the object showing the forces acting on the object. So we have the force of gravity, mg, the normal force, the ground, which is basically the collective force of all four on all four tires from the ground pointing up, and the force of the engine pointing to the right here. Okay, so those are your forces that act on the car. Second step is to sum the forces or add the forces up in the x and y direction. So I'm going to state, because this is on a horizontal surface, that the positive direction is to the right, and here in the y direction, up is positive, which is your normal convention for plus direction to the right and up, like a coordinate axis. So the second step is basically accounting for all the forces. So I go to the free body diagram and I say, are there any forces that point to the right or horizontally in the x direction? And I see one, it's pointing to the right, Fe for F of the engine. And it is accelerating, so I'm going to say x here. This box can be one of two things. It can be an x if it is accelerating, which in it basically says get rid of it, or it can be 0 if there is 0 acceleration. In this case, it is accelerating, so we'll just get rid of it. Okay, we don't need it. In the y direction, I see two forces, Fn for the normal force, and the weight, mg, downward, so it's a negative. And in this case, this is 0. There's no acceleration up or down. It's purely accelerating in the x direction. So what in effect I've done here is I've created a custom equation for the x direction, the forces in the x direction. And as you can tell, if there are many different forces acting in the x direction, this will become much more complex. So I'll get a different equation every time, but it'll have the form F equals ma. All the forces equal ma. Okay. Step 3, solve. And I put it up here in your homework. Put it right over here. Just for lack of space, I've moved it up here. I look at my force equation. I say, okay, to find the force in the engine, I have an equation. It's the x equation, which basically results in Fe equals ma. Okay, and I want to find Fe. All right, so I need to know the mass and acceleration. Well, I know the mass here, but I don't know the acceleration. So typically in some problems, if you don't know the acceleration, you're going to have to go to the kinematics model to solve for acceleration. So if you think back to the kinematics model, I have an object that's going from some velocity initial to a final velocity in a certain time frame. So as a side dish, you'd have to go off and write the kinematic equations, the variables, and solve for the acceleration. Once you know the acceleration, then you can say Fe is equal to that 1,000, because that's the mass of the car, times the acceleration rate you find from the kinematics model. So there's a side dish you're going to have to do to find that, which is kind of typical because force and velocity and acceleration are related. And you'll get so many newtons of force acting on the object. All right. So in summary, we have step 1 is to draw a free body diagram. And second step, we do a one-to-one correspondence of every force we see here in the free body diagram to the force equations. As you can see, I have 3 forces. 1 in the x direction, that's it right there. 2 in the y direction, those right there. And then I ask myself, is the acceleration 0 or not? I am accelerating, so I get rid of it. I'm basically getting rid of the box. In this case, I have 0 acceleration, so I put 0 there. And the equation I need to use for this particular problem is this first one. And then we have to go off and do a side dish to find the acceleration of the car to find the force. One final note. This force of the engine really is, if we go dig a little bit deeper here, is when you have a car that's accelerating, here's one of the wheels. It applies a backward force on the ground. It's actually the frictional static force. And the force on the wheel is forward. So yeah, the engine is supplying the force, but it works its way down the drive shaft and the drivetrain to the tires. And really it's the frictional force pointing forward. As this wheel rotates clockwise, it'll push back on the ground. The force in the tire is forward. So this is tire on ground, this is ground on tire. And ultimately, it's that frictional force that moves it forward. Collectively, we just say it's the force of the engine acting, which is the forward force, to push it to the right. So there's an example of the force model with horizontal acceleration.